Good day. This is another video on the Prelim of 2018 of Gauteng, paper 2. We are doing question number 9. It's about Euclidean geometry, specifically circle geometry. They gave us this diagram and this information next to it and some information on it. Firstly, they said in the diagram below, O is the center of the circle. So that is the center of the circle. A, B, C, D is a cyclic quadrilateral. So that red quadrilateral is a cyclic quad. Then they said BA and CD are produced to intersect at E. This produced always means that this is a straight line and that is a straight line. They said such that AB is equal to AE is equal to AC. And they indicated it for us on the sketch. They indicated with a line there, that red line, that blue line, and that green line is equal in length. Then they asked questions about this sketch. They said determine in terms of x the size of angle B2, angle E, angle C2, and then something else. We will get back to what they asked as we go. Remember they said determine in terms of x. The first one, determine angle B2 in terms of x. We may start by saying in triangle OBC, the red triangle here, angle B2 is equal to angle C3 because they are opposite radii. Then we can write 2 times B2 plus 4x equals 180 interior angles of a triangle. So that 4x plus 2 of those, because those two are equal, will add up to 180. Then we solve for angle B2. We can write 2 times angle B2 and minus the 4x on both sides. Then, by dividing by 2 on both sides, you can get the size of angle B2 equals 90 degrees minus 2x. Please stop the video and get your brain around this. I also then like to write this size in where it belongs. Remember they said determine in terms of x. They said next determine the size of angle E, angle over there. We could then write angle A3 is equal to 2x. Angle at center is 2 times angle at circumference. We know that the angle over there is twice as big as the angle over there for that reason. And we write it in on the sketch. Next we can write in triangle AEC, that blue triangle there. We can write angle A3 is equal to angle C1 plus angle E, exterior angles of a triangle. That exterior angle there is equal to the sum of the opposite interior angles. Next we can write line AE is equal to line AC. It was given to us that those two lines are equal, indicated with little lines there. Then we can write angle C1 is equal to angle E, angles opposite equal sides of a triangle. Then we can write 2x equals 2 times angle E. From A3 we know that A3 is 2x, and because these two are equal I can just call it 2e. Then we can divide by 2 right through and get x equals e. So the size of angle E is x. And I'd like to write it in on the sketch. Please stop the video and get your brain around this one. The third question, determine in terms of x, determine the size of angle C2. The first question was worth 2 marks, 5 marks, and this one's worth 3 marks. We may write in triangle ABC, the red triangle here. Angle B1 plus angle B2 is the same size as angle C2 plus angle C3. Angles opposite equal sides of a triangle. They told us that those two sides are equal. That means the angles opposite them will be equal. Then we can write angle B2 is equal to angle C3. We proved it in one above. 90 minus 2x is both of them. Then you can write angle B1 is equal to angle C2. You don't have to write the reason. I just write equals minus. If you look at this equation over here, and you minus equals on both sides, what is left will still be the same. And because those two black angles are now equal, we may write 2 times angle C2 is 180 degrees minus all the angles except the 2 black ones. And the reason is interior angles of a triangle. took the 2x and minused it. We took the 90 minus 2x, another 90 minus 2x, minused it. And if you do that calculation, you will see 2 times angle C2 is 2x. So the size of angle C2 is x. Please stop the video and get your brain around this. The last part of this question says, if angle E is equal to angle C2 is equal to x, prove that ED is a diameter of circle AED. We have to prove that this circle has a diameter of AE. They told us that is x, that we already filled in, and they told us that is x. We may write angle A1 is equal to angle BCD, exterior angle of a cyclic quad. So that angle there at A is equal to all those together. Then we can write angle A1 is equal to 90 minus 2x from there, x from there, and the other x from there. You can write C3 above, that's where it came from. If you add all of this, you'll get A1, angle A1 equals to 90 degrees, minus 2x plus x, no more x. Then you just have to write ED is the diameter of circle AED, converse of angle in a semicircle. Or if you like, line subtends 90-degree angle. Please stop the video and get your brain around this last part. Please indicate whether you liked or disliked the video and subscribe to the channel. If you run into a Euclidean geometry problem that you can't solve, you may send a clear WhatsApp photo of your problem to this number and a clear WhatsApp photo of where you tried it. Then we will try and solve the problem for you and send back an answer as soon as possible. Enjoy geometry.